All right, guys, let's get back to this. Really quickly, I'm not going to draw all cycles again, just for the sake of time. All right. So the graph looked like this. So in order to force this to be the inverse to be a function, force to be 1 and 1, guys, quiet, please. My interval is going to be from negative pi over 2 to pi over 2. However, I don't include them because they're asymptotes there. I'm not going to include them. Of course, my range is all real numbers, right? I know that. So that covers all possible tangent values. But in order to force the issue, I'm going to focus on negative pi over 2 to pi over 2, non-inclusive, so that the inverse of tangent is also a function. Does that make sense? Okay. Now let's move on to the next page, and hopefully we don't lose internet again. So let's look at the graphs of inverse sine, inverse cosine, inverse tangent. Let me zoom out a tad. Okay, now, just so you know, arc sine is another name for inverse sine. It's an old-fashioned term. Don't worry about it. When you see arc sine, it means inverse sine. You see arc cosine means inverse cosine. You see arc tan means inverse tan. Also, please, please, please do not think of this. Do not think of this as that. That's not true. Okay? That's not what's happening. Truly, what is 1 over sine x? Cosecant. That's a notation thing, right? When you see the symbol as a superscript as a -1, that's indicating inverse sine. If I really wanted to flip it as an exponent, I got to put this in parentheses and do that. Now, is that inverse sine? Yes. That would be 1 over sine x, which would be, sorry, is that cosecant x? My apologies. Sorry. Yes, that is cosecant x, right? If I do sine x raised to -1 in parentheses, that's 1 over sine x, which is cosecant x. Sorry for the confusion there. All right. Sorry, Tom? No, yeah, if you put parentheses around it, then it actually is going to be cosecant. So when you do it like this right next to the sign, that's going to be indicative of inverse sine, not cosecant. Just cos, right? Right. So let's think about it. X and Y have to switch because this is the same thing as saying sine Y equals X, right? That's the same thing. So Y now becomes the angle, and X becomes the output. For Y equals X, everything switches. So for example, let's do negative pi over 2. Let's do what should I do negative pi? No, let's do 0. Just keep it simple. And pi over 2. Okay, what's sine of negative pi over 2? -1. Sine? No, sorry, I meant to say 0. My bad. My apologies. No, wait, it is -1. Yeah, I know what I'm talking about. Sorry. What's sine of 0? 0. And what's sine of pi over 2? 1. So here's how it's going to look. That's a little bit better. That's how it looks. So what's happening, if I go to Desmos really quickly. Okay, what just happened? X equals sine Y. That's a reflection about Y equals X. Because if I do Y equals sine X, You see how the reflection about y equals x, if I were to graph y equals x, the reflection about each other. If I were to cut out a square piece of paper and fold along the black line, the green blue curves would map onto each other. But see how right now x equals sine y, does that pass the vertical line test? No. So you have to restrict it. And that's why it's restricted between negative pi over 2 and pi over 2 for y. Notice that that was the default domain for y equals sine x when we wanted to force it to be a one-to-one function. That becomes now the range for the inverse. Everything switches. So now my domain is from negative pi over 2 to pi over 2. Sorry, negative 1 to 1. My apologies. And my range is from negative pi over 2 to pi over 2. It all switches from sine. Let's do the same thing for cosine. Remember cosine, we went from 0 to pi. And that's 1, negative 1, and 0. Remember 1 and negative 1 were the outputs for cosine? Now they're the inputs. And my range is going to run from 0 to pi. It's going to look like this. Of course, the middle one's pi over 2. I'll try to sneak that in there. So it's going to look like this. Looks like that. Because if I were to graph it, it would keep going like this. It's kind of like a serpentine. Okay, good. At least the other one recorded. All right, just close that down. So this will be in 2 parts, this video. So that's how that graph looks. And then lastly, for inverse tan, I'm gonna look at negative pi over 2, even though I know it's undefined. I'm also gonna look at negative pi over 4. I'm gonna look at 0. I'm gonna look at pi over 4 and pi over 2. So clearly it's undefined there and there because I can't do tangent of pi over 2 or negative pi over 2. But I know that's gonna be negative 1, 0, and 1. Remember, this is the angle where everything switches. Because you're saying x equals tan y. Everything switches. So it's a little funky, but it's going to look like this. So undefined for x means it's actually going to be a horizontal asymptote. It's a little different. When it was undefined for y, we did vertical asymptotes. Now it's reversed. So you have to think of all this in reverse, hence the name inverse, right? 0, 0. Here's let's go black. 1, negative 1. Excuse me. Oh, what time's lunch today? At what time? 25? Okay. Hold on. Let me plot this appropriately. Now that passes the vertical line test, just so you know. But here's the thing. It's really supposed to look like this. That's how it's really supposed to look. So, yeah. Domains, all real numbers, because remember the range is all real for tangent, so it's reversed here. And my range is from negative pi over 2 to pi over 2, non-inclusive. But really, if I did x equals tan y, let me clear this for a moment. I'll come back, don't worry. See, it looks like that. But I have to restrict the range to show just one cycle. Therefore, it's to passes the vertical line test. Okay. So that's what's happening with all that. Those are the graphs. So we have the following. So y equals inverse sine of x if and only if y sine y equals x. So the domain, again, excuse me. Because that's gonna be the output. Likewise here. And then the range, again, was in parentheses here. So we gotta make sure we're clear on all that before we move forward. Say a question, please. Go ahead. What was that? Oh yeah, of course. Yeah, go for it. Okay, so everything switches from the regular functions. We're okay with that. Cool. All right. Okay, now let's actually do this is actually unit circle stuff. Don't talk about compositions. Don't talk about evaluating. And the more I think about it, I'm not going to do part 6. I am not going to get there because that's too much on you guys. So I think we could do 2 more pages before 12:15, and we'll do the homework quiz. Okay. I think we're okay with this. So what you want to do here, this is purely unit circle stuff again. Hint, hint, meaning our next homework quiz will probably be something like this. Okay. So you have to do, so these are now, so the inputs, just, are coordinates on the unit circle. Okay, the inputs are coordinates in the unit circle. The outputs are angles. Radians or degrees. Okay, make sure we're clear on that. I don't want any confusion. Those inputs are not angles. Those inputs are coordinates on a unit circle. Or the ratio of sides of the right line. Like, for example, when I see root 2 root 2, what this tells me is that the adjacent side of root 2, the hypothesis 2, give you the angle that provides that. That's what this question is asking. Or what coordinate does cosine correlate to in the unit circle? What coordinate does cosine correlate to? X, good. That's the x coordinate. Give me the angle that goes with that x coordinate. That's what this question is asking for. Yeah, 5/4, exactly. So let me pull up the unit circle so we got it. Because I think it's good for us to have a unit circle ready to go. And you have to use a default range. You gotta use a default range too. Here we go. So let me clear this for a moment. Let's explore let's explore root 2 root 2 really quickly. So okay, look at the unit circle. I have inverse cosine of root 2 root 2. Where is the x coordinate root 2 root 2? Totally right there. Where else is the root 2 root 2? Right here. And by the way, can I go around many times, backwards, forwards, counterclockwise? Yeah, sure, why not, right? But our default range, so we don't drive ourselves nuts, and so that inverse cosine stays as a function, our default range is the top half of the unit circle, from 0 to 180, or from 0 to pi. So from the top half, cosine's positive clearly over here. What angle correlates to that? 5/4 or 45 degrees. So the answer for part D is going to be pi/4 or 45 degrees. Whether you give it in degrees or radians, I don't care. If I do specify, then of course, given the right unit that I specify. But if I don't specify, you can do radians or degrees. I don't care. Because remember, the output is an angle, right? Because cosine 45 degrees equals what, guys? √2/2. It's all reversed. While we're at it, let's look at part. Ooh, that's a typo. That should be part E. Okay, where is the x-coordinate -½ Where's the x-coordinate -½ guys? What's that? 2π/3. Thank you, Sean. But we're gonna say 2π/3. Okay, we're cool with that. Yeah, good. All right, let's take a look at A. Okay, where's the y-coordinate -√3/2? And now remember, for inverse sine, we gotta look at the right half unit circle. Our default range, even though it's 3π/2, that's still -π/2, right? -π/2, π/2. So focus on the right half unit circle. So, Kyle, where you had your hand raised, do you know where it is? Where the y-coordinate is -√3/2? Yeah, but instead you're gonna say -π/3. Correct. Zay, go ahead. But it's not part of our default range. Because our default range from -π/2 to π/2. You are correct. But we have to give in the default range. Or -60 degrees. Pretty much for inverse sine, but inverse cosine can have acute and obtuse. Because it's from 0 to 180. Okay, arc sine. Arc sine, same thing as inverse sine. 1/√2 is the same thing as √2/2. It's the same thing as saying this. So where does that happen? What angle? π/4. Or 45 degrees. Okay, inverse sine of 1. Where's the y-coordinate 1? At π/2. Or 90 degrees. So that's what you're looking at. Inverse sine's y-coordinates, inverse cosine's x-coordinates. Inverse tan's kind of a fun one. Inverse tan is y/x. Right? So you guys see where's y/x -1/√3. That one's a little tricky. So you need to have √3 involved. It's going to be y/x. Don't do this one. First of all, don't do any of these. These are positive. Remember, default range is -π/2 to π/2. That's default range for inverse tan. You want -1/√3. Let's do that one, right? y/x. y/x. The y-value is -1/2. The x is √3/2. But you're going backwards, clockwise. -π/6, exactly.
Oh, you have to go backwards.
Yep.
You can start at -6.
Nope. So the default range.
Because that would make it look like into the
Triangle has to be between those two. That happens at -π/6. Or -30 degrees. Say it, go ahead.
So how would you do B then? Because whenever cosine is negative, it wouldn't be in a default range.
You mean this one right here, this B? That was supposed to be E, yeah. No, the default range for inverse cosine is from 0 to pi. Because they had a different default range. Because remember when we graphed the cosine, in order to force the issue of being 1 to 1, it was from 0 to pi, it was different. Because that made it pass the horizontal line test. Whereas for inverse sine, it was from -π/2 to π/2 to pass. And for inverse tan, it was from -π/2 to π/2 as well, non-inclusive though. You have to think graphically about the original graph and force an issue of 1 to 1. That's what you have to do. Okay, compositions, and then a few other crazy ones, and then we're done. You guys should know this. If you plug the inverse into its original or vice versa, it should always equal x. So I'm not sure what's supposed to be in the blanks there. Yeah, I guess so. Yeah, hold on. Let me. Are you right about that, Sean? Hold on. Yeah, I think you're right, Sean. Bottom line is you plug in the inverse to itself, you get the same, you get X or Y, right? That's what's all that's what we're trying to say here. And that's going to be thank you, Sean, for helping out there. Again, you plug an inverse into itself, they knock each other out, right? It's kind of like if I did square root of X squared. Technically, it's absolute value of X, but you pretty much get X, right? It's kind of like that. Or if you did X plus 5 and then minus 5, you get back to X, right? Because you do the inverse, or X times 5 divided by 5, right? Or if you do like natural log of e to the X, it's X. That's all we're saying there. So okay. This is the fun problems. I like these problems a lot. And then in a few minutes, we'll do the homework quiz. Okay. Remember what this means. That's theta. That's theta. Okay. That's theta. This whole thing here will be theta. This whole thing here will be theta. Okay, now I got all primed. Okay. So inverse sine, the output's always an angle. Whenever you have inverse sine, the output's an angle. Likewise with inverse sine over here and inverse cosine over here. For CDE, the whole expression is going to be an angle. You're doing inverse cosine of this junk here, right? Well, likewise, you're inverse sine of all this junk here. Or inverse sine of all that junk there. So let's take a look at A. Here's how I'd approach this one. I draw a right triangle. Call that theta. What's my opposite side? What's my hypotenuse? What's my other leg? Root 5. But what's the sine of all that? It's still going to be 2/3. Right? Because that's what this represents. This expression, arc sine, is an angle of a right triangle. Opposite of hypotenuse, right? What this is telling me is that sine theta equals 2/3, right? That's where it came from. Sine theta equals 2/3. I know it was redundant. I didn't have to do that, but I wanted to show that to you guys, right? So, like for example, if I switch this to a cosine, let's say I switch that to a cosine. What would the answer be now? That'd be root 5/3, right? Correct. Yeah, because where did this come from? Okay, guys, quiet, please. Let me get through this. So what does this mean again? This means theta equals inverse sine of 2/3. So isn't that the same thing saying sine theta equals 2/3, right? Because why did we get the inverse in the first place? We switched the input and outputs, right? So these are the same thing. That's why I could draw that right triangle like I just did. The 2 represents opposite, the 3 represents hypotenuse. The arc sine as a whole represents an angle or theta. Now, let's look at part B. Is that possible? Nope. Think about it. Can that happen? No. How can a leg be long as hypotenuse? That can't happen. Because what's 3 as a fraction? 3/1. Can the opposite be longer than hypotenuse? No way. So it can't happen. Can't happen. Okay, let's look at this one here. So now let's just kind of use unit circle at this point. Because now we could just kind of use unit circle to help us out. What's the inverse cosine of negative root 3/2? So what angle, cosine of what angle gets me negative root 3/2 in the default range for inverse cosine? Let's go back to unit circle again. Where's the x coordinates? 5 pi over 6. I like it. Good. And what's cosine of 5 pi over 6, guys? Just back to negative root 3/2. So they kind of knock each other out. No, it is because what's the range for inverse cosine? 0 to 180. Right. Correct. No, but this is negative though. We have negative root 3/2.
Oh, I see.
Right. Okay. Here, you're going to say pi over 7. Because they knock each other out. So C is just pi over 7. However, for D, you can't just say the answer is 2 pi over 3. Careful this one. You do inverse tan. What's tan to 2 pi over 3? According to the unit circle, that's going to be negative root 3, I think, at 2 pi over 3. Yeah. Okay. However, what's the default range for inverse tan?